In this video, we are studying parallelograms, the mensuration of parallelograms. So a parallelogram is basically a quadrilateral, that is a four-sided figure that has two opposite sides equal, and those two opposite sides are in parallel to each other. So this side is parallel to this side, and this side is parallel to this side. So that is why it is called a parallelogram. These are parallel lines, these pair are parallel lines. These lines are equal to each other, these lines are equal to each other. And therefore, this angle is equal to this angle, and this angle is equal to this angle. So opposite sides are equal, and opposite angles inside a parallelogram are equal. Now, the formula for the area, we're in plane shape, so the area of a parallelogram, it depends on the information about the shape given. If height and a base, remember that height is always perpendicular to the side we call the base. So if height and base we are given, remember in a triangle, the popular formula for area of a triangle is half base times height. For a parallelogram, that half goes away, because actually a quadrilateral is made up of two triangles, right? So it's base times height. That's the area. Then, just like in the triangle, if an angle is known, that is two sides and an included angle is known, it becomes those sides multiplying each other. AB sine theta, sine of the angle given, the included angle. If it were to be a triangle, it would have been half AB sine theta, because the triangle would have gone this way, dividing the parallelogram into two sides. So we have this formula for the area, and as well as this formula for the area. Now we are going to solve some examples to help us make use of this information. Okay, right here we've been given this parallelogram, and we've been asked to find the area of this parallelogram. So we are given this. Remember that a parallelogram is base times height. Since an angle is not included, so we won't say two included sides as these sides and then one angle. No angle was given. So we are going to be using base times height. Remember, the height is always perpendicular to the side we are going to choose to call the base. Okay, so we know the base. We don't know the height, but we know this side. And seeing that this is angle 90, right? We can use right angle triangle, that is Pythagoras theorem, to find this height. Okay, so we could as well draw that differently, or let's just look at the shape. So this side 13 cm is opposite the angle 90, so this is the hypotenuse, right? So we have that hypotenuse squared is equal to this other side squared plus, let's call this place x squared. Now remember it's the height, right? Or you can call it h, but let's just call it x. So x squared is equal to 13 squared minus 5 squared. Okay, so this is a difference of 2 squared. So remember that this difference of 2 squares is equal to this plus this, and itself minus the other. 13 plus 5, that is 18 times 13 minus 5. 13 minus 5, that is 8. 18 times 8. Oh, didn't really look that easy. So we are going to use our calculator to find that this is equal to 144. And then x is equal to the square root of 144, right? Which is 12 cm. So we have that the height is 12 cm. Therefore, we'll now look for so remember that the area of a parallelogram, area is equal to base times height. So the base is 7 plus 5. 7 plus 5 is 12. So which is 12 times this height we found now, 12. 12 times 12 is 144. Its area, so it's in units squared. Right now we are presented with this. So this is 8 cm. So we are presented with this shape. So we can see that this is a parallelogram, right? With this additional triangle here. And we can see that this height represents both the height of the parallelogram and the height of this additional triangle. But let's look at it carefully. We can see that if the area of triangle PSR, so if the area of this triangle here is 36 cm squared, find the value of this line QR. Okay, so let's look at it from what we know. We know that, or when we look at it PSR, so we've been given the whole area like this. So remember that the area of a triangle is equal to half base times height. So the area of this whole triangle is equal to half base. Remember that the base is the side that is at angle 90 degrees that is perpendicular to the height, right? So this 6 represents the height. So this area, 36 cm squared, the area of this triangle PSR, is equal to half base. So half, the base is now P to R. But now we've been given that this side TS is 8 cm. So remember, a parallelogram, its opposite sides are equals. Therefore, PQ is 8 cm. Then this QR, which we are looking for, we don't know yet. So we can safely say that the base is equal to 8 plus. Now, what do we call this QR? Just a single letter that we can call it. I always go for the letter X. So to say that, let QR equal to X, right? So this part is X. So 8 plus X times the height, which we can see here is 6 cm. So half base times height, which is 6. So we can see it's already solved. So 2 into itself is 1, 2 into this is 3. We are going to divide both sides by 3. So we have that 36 over 3 is equal to 8 plus X. So 3 into itself is 1, 3 into 36 is 12. We have that 12 is equal to 8 plus X. Now we are going to make X the subject formula by sending 8 over to this side. We have that X is equal to 12 minus 8. So 12 minus 8 is 4 cm. Remember that we said that let QR be equal to X. So therefore, QR is equal to 4 cm. Did you see how we use the knowledge of triangles and parallelograms to solve this question? Easy and nice.